Lesson 11, graphs of linear inequalities. So we've graphed linear functions, and in the last lesson, well, we learned that we didn't do the last lesson, but you guys know this, that the points that lie on a line are simply the xy pair that makes the equation true. So when we graph an inequality, any type of inequality, we know that there are many solutions. So the same holds true when we graph an inequality in the xy plane, meaning that we're putting it on the coordinate axis. So it says graphing inequalities. To graph an inequality simply means to plot or shade all xy pairs that make the inequality true. So that's definitely something that is worthy of highlighting. Okay, so to plot or shade all xy pairs that make it true. Okay. So it says, consider the inequality y is greater than x plus 3. Determine whether the following points lies in the solution set and thus on the graph of the inequality shown. So we're going to be looking for a true-false situation. So there's our x and our y, and I don't know why my stylus just grabbed it and moved it. See, I'll move it back. There we go. Okay. So let's do that substitution. So we say 7 is greater than 2 plus 3 is 7 greater than 5, and that is absolutely true. So 2, 7 is one of the solutions to that inequality. Do the same thing. 4, 0, 1 is 1 greater than 0 plus 3 is 1 greater than 3. Well, that's totally false. Okay, so that's not one of the solutions. And then this last one, 1, 4, so is 4 greater than 1 plus 3 is 4 greater than 4, and that is also false. So 1, 4 is not one of the solutions. So it says, graph the line y equals x plus 3 on the grid below in dashed form. So instead of making a solid line, they want us to make a dotted line. So it says, why are the points that lie on this line not part of the solution to the inequality? So let's go ahead and do what they're asking, so that we've got a graph y equals x plus 3. Well, my slope is a positive 1, and my y-intercept is positive 3. So if I go up 3, and then if I go up 1, right 1, according to my slope, or I could reverse it and go down 1, left 1. Okay, and they said that they want this to be a dotted line. All right, so let's use this. Okay, so something a little bit different than what we're used to seeing. It says, why are the points on this line not a part of the solution set? Because when we graph things and we pick points on there, we make it a solid line because all of those points that are on that line, integers, it's all real numbers, your fractions, your decimals, your rationals, your irrationals, all along that line make that equation true. So if we make it a dotted line, okay, those points that lie on that line would make it false. Okay, so we graphed that. Now it says plot the 3 points from part A, so way back up here, those 3 points, okay, and use them to help you shade the proper region of the plane that represents the solution set to this inequality. So think about back when we solved just regular plain old inequalities. If we had something like this, I'm just making something up here, x is greater than 4, we would subtract 3 from both sides, and we would get x is greater than a positive 1. And then we would go and we'd put our solution set on a number line, and we would say that that is an open circle. It's greater than 1, and I'd shade. Okay, so we came up with x is greater than 1, and it's not equal to, so we had that open circle, and we shaded everything to the right, because all of those solutions to the right of 1 make this inequality true. So now we're looking at it in the xy plane. So we've got those two values, the x and y. So they want us to, so we're going to need to determine something here, where we're going to shade this, where other solutions are. So 2, 7, if we plot that, So 2, 1, 2, 3, 4, 5, 6, 7. So 2 sevens there. 0, 1 is on the other side of the line. And then 1, 1, 2, 3, 4, that sits on the line. Okay, so plot these 3 points and use them to help you shade the proper region of the plane that represents the solution set to this inequality. So 2, 7, okay, came out to be true. Okay, so on that side of the line, I bet if we picked some other points to the left of this line or about this line, they would come out to be true. And then 0, 1, when we checked it in that initial inequality, it came out to be false. So 1, 0, 1 is not a solution, so that's not in the direction that we would shade. Just like over here, back to this one that we're familiar with, the solutions to this were to the right. They were greater than, so that's why we shaded to the right. So this one below, this 0, 1, is false. Well then, what about that 1, 4 on the end? Okay, and where does 1, 4 sit on our graph? 1, 4 sits right on that dotted line. Well, that's how, when we graph in the XY plane, that's how we indicate, okay, an open circle. Okay, on just our number line, we have that open circle. We don't have that option when we're graphing. So when we're graphing this whole line, which would indicate that it's not equal to, we would make a dotted line. So all of these points up here, up and to the left, are going to be our solutions. So I put a big S there. Okay. Now it says choose a 4th point that lies in the region you shaded and show that is a solution to the inequality. So I don't know. Let's try -1, -2, -3, 2, -3, +2. And y is greater than x plus 3 was our initial inequality. Let's see. So is 2 greater than -3 plus 3, and is 2 greater than 0? That is absolutely true. Okay. So the point 10, 12 cannot be drawn on the grid above, so it's difficult to tell if it falls in the shaded region. Is 10, 12 part of the solution set to this inequality? Show how you arrived at your solution. So if we can't see 10, 12 on on that particular graph, do the same thing. Check it algebraically. So is 12 greater than 10 plus 3? Is 12 greater than 13? Well, that is false. So 10, 12 would not fall in that shaded region. Okay, go ahead and flip the page. There's some challenges to graphing linear inequalities, especially if the output y has not been solved for. Let's look at the worst case scenario it says here. So we've got this inequality here. Rearrange the left-hand side of the inequality using the commutative property of addition. So we're just going to flip the order of this. Okay, so we rearranged it. Now it says solve the inequality for y by applying the properties of inequality that we used way back in Unit 2. So what we've got to do is we've got to get this in y equals mx plus b form so we can start to graph it, so we can find that slope in the y-intercept. So I'm going to subtract 3x from both sides, because remember, I'm trying to solve for y. So -2x is greater than or equal to -3x plus 2. And then to get y by itself, I've got to divide by 2. But if you recall, what happens when we divide by a negative? Okay, we've got to flip the direction of the inequality. Negative divided by a negative is a +3/2 x. +2 divided by -2 is a -1. So we solved it for y. And where does it ask us to graph it? Shade the solution set of the inequality on the graph below. Okay. So first of all, we've got to graph this. So my slope, +3/2. My y-intercept is -1. So, and then I'm going to go up 1, 2, 3, and over 2. 1, 2, 3, and over 2. Now it's equal to, okay? So on a regular number line, an equal to would indicate a solid or filled in circle. So what are we going to have to do on the XY plane? We are going to make that a solid line, okay? So we've got a solid line. We're going to extend it. We're going to put arrows on either sides of it, okay? And then we've got to shade where our solutions would be, shade the solution set to this inequality. So it says pick a point in the shaded region and show that it is a solution to the original inequality. So how do I decide where I'm going to shade this? Are my solutions up and to the left or down and to the right? Because, you know, when we graph on that number line, we know that greater than goes to the right and less than goes to the left. Well, the same holds true here. So if y is less than or equal to, the equal to is taken care of by that solid line, less than, okay? Where are my y values less than? Okay, y values less than. So the y values that are less than are going to be below this line. And then when you're in doubt, pick a point in that line and then test it into the original inequality. So if I pick, I don't know, let's pick this point right here, which is 1, 2, 3, 0. So let's test 3, 0, and we always go back to the original, okay, to do our check to see that we shaded properly. So 3 times 3 minus 2 times 0, is that greater than or equal to 2? So we end up with 9 minus 0. And yes, 9 is certainly greater than or equal to 2. That is true. So yes, we did shade in the proper direction. So down and to the right, those would represent all of my solutions, as well as any of these points on this line, because it is a filled-in line. Okay, it says the final type of inequality that we should be able to graph quickly and effectively is one that involves either a horizontal or vertical line. Okay, those are one of the last couple lessons that we did. It says shade the solution set. First, state in your own words the XY pairs that the inequality is describing. So x is less than 4. X is less than 4. Okay. So if I graph x is less than 4, okay, x is going to be that vertical line. So, and it's not equal to, so where is 4? 1, 2, 3, 4, so it has an x-intercept, and it's going to be a dotted line, okay, because it's not equal to 1, 2, 3, 4, dotted line. And now where are all the values of x less than 4? All the values of x less than 4 are to the left of that. And then again, if you're in doubt, pick a point. And if you can, pick 0, 0, just because it's the easiest. And check that. Is 0 less than 4? That's absolutely true. And this last one, y is greater than or equal to negative 2, and it's equal to, so y is greater than or equal to negative 2. So negative 2, and it's, whoops, negative 2, and it's y, so, and it's equal to, so it's a solid line. And where, and it's horizontal, okay, it's got to go through the y-axis. Y is greater than, where are all the values of y greater than? They're above that line. Oh, by the way, we should label these, and you always label on the solution side, because that's what you're labeling. You're labeling the solution set. X is less than 4. And again, pick a point. If you can, pick that 0, 0, just because it's easy. Is 0 greater than or equal to negative 2? And that's true. Okay, so you've picked a point on that line. So hopefully that went rather quickly and easily. See you in class.
Okay, Mom.
It's not,